Hello and welcome to AnalyzerPro Shorts, the series where we show you bits and pieces of AnalyzerPro that should help and inspire you for your daily work as an expert. Today I would like to discuss a quite useful kinematic module called calculation or calculate path time. And it's useful when you have a situation where you know a total distance of the combined behavior of reacting, build up the brakes and braking, but don't know exactly how and where what of these things happened. So let's have a look at this situation. We have a collision with a truck and a car, and probably the car said, yeah, when I went over this pedestrian crossing, I saw the truck and immediately braked. So for us, immediately braked means actually that he reacted somewhere over there. And we would like to find out when he actually braked and how the situation looked like. So let's assume we just have done a collision analysis and we found out the collision speed here of this car was probably 30 kilometers per hour for the sake of making this example simple. I'm going to use this measurement tool now and measuring. Okay, so we have 43.5 meters for a total behavior, or for this total driving path, where we have first a reaction phase, then a build-up phase, and then a braking phase. And then we're ending at 30 kilometers per hour. So let's have a look at the module and see what we can do with it. Module, and then calculate path time. Selecting vehicle number 1. So we see a bunch of values here, and out of these values we need to enter 5. Good thing is reaction time of 1 second and build-up time of 0.2 are default values and we can use them right away. Of course, feel free to adjust. Then what else do we know? Well, we don't know the initial velocity. We also don't know the braking distance. We don't know the braking time. We can make an educated guess about deceleration. So let's say it's dry ground, then he was more or less fully braking. So let's say, give him 7 meters per square second. Final velocity, we said, okay, he collided with 30 kilometers per hour, and then total distance would be our 33.5 meters. 43. And I can immediately click on calculate. And yeah, the magic happens. So what it does, it splits up these phases in reaction, build up and brake. We can place this here. We can have a look in our main data window. You can see braking, build up, reaction phase, all lined up properly. We see, okay, braking time was 1.4 seconds, braking distance 20 meters, initial velocity 70 kilometers per hour, total time of 2.69 seconds. But we can also see, okay, he was probably missing roughly 5 meters to get the braking fully done. So we can not only use that as a situation or a tool to directly calculate this movement, but also for a bit of avoidance. There are further avoidance or more sophisticated avoidance modules in Analyzer, but this one at least gives you a certain hint. And of course, you could add further calculations for calculating different versions of that accident. For example, let's say we want to have an alternative calculation where he was, don't know, maybe just braking with 5 meters per square second, ending with 30 and going for 43.5 meters. You can click on calculate and see, okay, that would change to 63 kilometers per hour initial velocity. We could, instead of putting in these values, put in other values to find out. For example, I can add another column here and say, but what if, or how would the situation look like if the collision speed wasn't 30, but the collision speed was maybe 20, but he was fully braking. So, or I know probably the initial velocity and so on. So I can calculate a lot of alternatives that help me as an expert examine how different approaches, how slight changes in the calculation would affect the total result. I hope you found this little video useful, enjoyed it, and yeah, thanks for watching and have a great time. Bye bye.